This video is for Unit 3, radicals. It's lesson 3 on multiplying and dividing radicals. I'm probably going to split this up into 2 videos, but the goal of both videos, by the end, we're going to be able to multiply and divide radical expressions as well as rationalize the denominator when needed. So to multiply radicals, you need to know something called the product rule, okay? So if I have the nth root of some number a times the nth root of some number b, that is going to equal the nth root of some number, now a, times b. Really, I should be saying expression instead of number because it's going to be an expression underneath your radical more than likely. Our rules to keep in mind is that the nth root of a and the nth root of b must be real, meaning you have to be able to do them. For instance, the square root of -4 is not possible. It's not going to have a real root. So right now we can't do them. All right. And the other rule is that the index, or the n, of each root must be the same. So if you look at our first example, we have the cube root of -5 times the cube root of 25. So they have the same index. It's 3, so that's good. You can take the cube root of -5. You can take the cube root of 25, so let's do it. So we're going to do the cube root of -5 times 25, but -5 times 25 is -125. The cube root of -125 is -5. Since -5 times -5 times -5 equals -125, the cube root of -125 is -5. Our second problem, we have the fourth root of 4 times the fourth root of -4. Now they both have the same index, but if you look at your second part of this multiplication problem, it's asking you to take the fourth root of a negative number. You can't take the even root of a negative number and get a real solution, a real root. So right now we're going to say not possible, at least for now. Our next example, if I flip to my next slide, is the square root of 2 times the square root of 8. They both have the same index of 2, and they're both possible. So the square root of 2 times the square root of 8 is going to become the square root of 16. The square root of 16 is plus or minus 4, because 4 times 4 equals 16, and -4 times -4 equals 16. You don't have to worry too much about the plus or minuses yet, but it's good to have for the future. Now we have the next problem, which is the square root of 3 times the cube root of 3. Well, they're both possible, but hang tight. Sorry, they made an announcement, so I wanted to take a moment to pause my video. So we have the square root of 3 times the cube root of 3. Now, they don't have the same index. One's a square root, so the index is 2, and the other's a cube root. So we can't do this for now. Moving on to our next problem, we have the square root of 6 times the square root of 2x cubed. They're both possible, all right, and they both have the same index, which is 2. So the square root of 6x times the square root of 2x cubed is the square root of 12x to the 4th. Now we've multiplied, so now we just simplify. Well, 12 is even, so we can divide by 2 and we're left with 6. 6 is even, we can divide by 2 and we're left with 3. X to the 4th is the same as x, 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 and x. Now it's just like playing Go Fish because the rules of the game are pairs, 2 of a kind. I see 2 2s, I see 2 x's and another set of 2 x's. So what comes out? A 2 and x and an x, or x times x, which is x squared. What's left inside? You have a 3. So we have 2x squared square root of 3. The next problem, we have 2 square root of 2x times square root of 6x. Well, the 2 is just a coefficient, just like a 1 would be in front of the square root of 6x. So don't worry too much about that. Also, they both have the same index of 2, and underneath are both possible. So we have 2 square root of 2x times 1 square root of 6x. That's going to be 2 square root of 12x squared. Now we simplify. So we've multiplied, so now we simplify. 12 is the same as 2 times 6. 6 is the same as 2 times 3, and x squared is just x times x. The rules of the game are 2 of a kind. So I see a pair of 2's and a pair of x's. What was already outside was a 2. What am I taking out? A 2 and an x. And what's left inside? A 3. Cleaning that up, we end up getting 4x square root of 3. My last one is slightly more difficult. So I have square root of 2 times 3 square root of 4 minus 3x square root of 6x. So what we can do is we can just distribute. So I'm going to multiply the square root of 2 times 3 square root of 4 and times 3x square root of 6x. So again, I just have a coefficient of 1 here. So 1 square root of 2 times 3 square root of 4 is 3 square root of 8. I'm going to put the minus sign because there is a minus sign there. 1 square root of 2 times 3x square root of 6x is going to be minus 3x square root of 12x. And now I just need to simplify. So 8 is the same as 2 times 4, and 4 is the same as 2 times 2. I'm playing by my rules of pairs, so a 2 comes out here, leaving me with 3 times 2 outside, or 6, square root of 2. For my second part, I've got 2 and 6, and then 2 and 3. I'm looking for pairs. I see a pair of 2's. What's already outside, well, a minus sign, and then 3x times 2, which is 6x, and left inside is the square root of 3. So there we go. Now I did some dry erase practice, and I'll do those as well with you. So here's our next problem. We've got 2 square root of 4x cubed times the square root of 3x. We have the same index and both are possible. There's also a coefficient of 1 on this second part of my product. So I have 2 square root of 4x cubed times 1 square root of 3x. That's going to get me 2 square root of 12x to the 4th. I've multiplied, so now I'm simplifying. 2 and 6, 2 and 3, and then x, 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 x. The rules of the game are pairs, 2 of a kind. So I see a pair of 2's and 2 pairs of x's. Now what's already outside? There's a 2 already outside, and I'm taking out a 2, an x, and an x. What's left inside is the square root of 3. Now clean it up, and you end up with 4x squared square root of 3. Now I've got the square root of 8c times negative 2 square root of 9c squared. So this is a 1 square root of 8c times negative 2 square root of 9c squared. That's going to be negative 2 square root of 72c cubed. Where am I getting the 72 from? I'm multiplying 8 times 9. Where am I getting the c cubed from? It's c times c squared. Now I've multiplied, so now I'm going to simplify. 72 is even. 2 and 36. 2, hold on, I'm back. So 36, 2 and 18, 2 and 9, 3 and 3. C is the same as C, or C cubed is the same as 3C's. So the rules of the game are pairs. I see a pair of 2's and a pair of 3's and a pair of C's. Now what was already outside, a negative 2, I'm going to multiply that by 2 and 3 and C, and what's left inside, we've got a 2C. Cleaning that up, that's going to get me negative 12c square root of 2c. Okay, if you look at the next one, we've got the cube root of 5p times the cube root of 25p to the 6th. So same index, both are possible. It's going to become the cube root of 125p to the 7th. Now it's really nice if you recognize 125 is a perfect cube. So I know the cube root of 125 is actually just 5. But if you don't know that, break it down. 5 and 25, 5 and 5. P to the 7th is p, 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 and another p. The rules of the game are 3 of a kind. So 3 5's, 3 p's, 3 p's. So I've got a 5. I'm taking out 2 p's, or p squared. I'm left with the cube root of, well, just plain old p. So that's how you multiply. Practice, 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 and come back to class with questions.